I have a question here under the application of Newton's Newton laws of motion in physics. For those doing foundational physics, this is something that you need to look at. The question says a sled is tied to a tree on a frictionless snow-covered hill. So this is frictionless. That means we are not taking into consideration friction. If the sled weighs 77 newtons, find the magnitude of the tension T here and the normal force. We're looking for T and the normal force that is being exerted by the loop here. We have a loop, this is a tree, and this is a sled. Okay. So before we go anywhere, so this is a hill and this sled here has been inclined at an angle of 30 degrees. So this is a ground, the level ground. So before we go anywhere, let us first draw a free body diagram. That was going to help us solve this question. All right, so let us first draw the free body diagram. So I'll draw it like this. So follow me properly. So I will present a sled with this type of thing. So the normal force, take note that, okay. First, let us start with the weight. The weight will always be downward like that. Okay, so this is the force due to gravity, which we call mass times gravity. So this is the angle here. Now the normal force will always be perpendicular to the object. So this one here is the normal force. Let me show it with a small letter. This one here is the normal force. It will always be perpendicular to the position of the object. Take note of that. But if we extend this, you discover that there will be another line which is in the same position but in the opposite direction as the normal. All right, that one will help us resolute the forces acting on this sled. Are we together? So this angle here, according to the angle property, is the same as the angle here. They are the same. It's the same. Now if I close up here, I'm going to form a triangle like, even if I do this, I'll form a triangle like, you get the concept, in which I need to find the forces in the x, okay, and the forces in the y. So I have to resolute the forces. So how do I resolute the forces? One thing that you need to know that the object should always be in the x-axis, okay, while the normal force should always be in the y-axis like that. Okay, so the object direction should always be in the x-axis, while the normal force should always be in the y-axis. Is it making sense there? Okay, so if I have to resolute the weight of the object, since the weight is here, right? Isn't it? And this is the x. If I want the y component, now take note, for this triangle alone, this triangle which I'm showing here, this triangle, this is the x for the triangle, okay, and here this is the y for the triangle. This is the x, this is the y. Even if you tilt it like this, try to tilt the video, you discover that this is resting like that. That means the x is always associated with what? With cosine, while the y, the sine. Now take note that this x here is pointing downwards, right? That means this force which is pointing downward here, it will be, because it's pointing downward, right, to minus mg cos theta. Then this one here in the y, it's also pointing in the negative direction. Remember, it's pointing like this, so it's going in the opposite direction, right? So this one will be so negative mg sine what? Sine theta. But this is parallel to this plane here. That means the force acting like this is the same thing as this one here, because they are parallel. Remember, parallel, they are equal. So we've seen how we've resoluted them. Now, what is going to help us and solve this question is that we need to establish two conditions for equilibrium. The first one is that the sum of forces, right, in the x should be equal to what? 0, as well as the sum in the y should be equal to what? 0. So if you apply Newton's second law of motion, of course, this is not moving. It's been tied, by the way. So we assume we are going to say acceleration is 0. It's been tied, so it's not moving. It's stationary. So the acceleration is 0. Because of that, that means all the forces that we have should give us 0. All the forces that we have should give us 0. What forces do we have? We have the tension here. So we have the tension. We have the normal force, which is of course is in the positive direction. Then we have this force here. Let's call it the force due to gravity. This should always give us what? 0. This is a very important condition. Now let's find for x-axis. So for x, in the x, which one do we have? We have the tension. We also have this one here. It's in the x. Sorry, this one here. It's in the x, right? You can see it's in the x there, right? So we have tension minus mg, okay, sine what? Sine theta. Then in the y, we have, let's go to in the y. We have this one here is the normal. Which one else do we have? We have this guy here. Okay, so it's pointing down, right? Same line as that one. So in the y we have n minus mg cos theta. What we are saying that all these, when you add them, should give you 0. So this one should be equal to 0, and that one should be equal to what? 0. So this we put 0 guide. It's the same. Tension will remain. This is 77 sine what? 30. Here is 0. N minus 77 cos what? 30. So here I can already say that the tension will come out clearly. Let us punch on the calculator. So I'm getting 38.5. I'll leave it one decimal place as the tension. Then how do we find the normal force? We'll find it then the normal force in the y direction for the forces acting in the y direction. So we're going to have cos 30, you punch, then all right, so we get 66.7. I'll leave also it to one decimal place, just like that. So once you know how to resolve these, it becomes really easy for you. Okay.